right, the last section of key features of graphs is when we can transform the graphs. So when we transform graphs, these are the basic rules. So we have a parent function. The parent function is the where you started. The image or the child function is what what the function's equation is after. After the image. After you've transformed it. So take a minute to read this. Okay, when you f of x, remember f of x is our y. When we add to it, we move up. When we subtract, we move down. So we take a whole figure, a graph. Now you did this last year with shapes. Now we're doing it with functions. A tricky one is left and right. So if we add to the x, okay, we're adding to x, but we're going to move left. Moving that way. Moving to the right, go this way. This is my way of just having you read this. Okay. So moving down, we have reflections. So this is similar to our odd and even. But if we reflect the whole graph, if we put a negative, if we change the x, it reflects it through the y-axis. If we change the y, we put a negative on the y, it reflects it through the x-axis. Sorry, I was reading the wrong thing. Dilations are very interesting, but the basic idea is they do visually do the same thing. When you multiply times the y and you multiply times the x, visually they look exactly the same. See, this is inside the parentheses here, right next to the x. This is outside the parentheses, so it's not squaring the 3 here. So these two, this one is changing the y, this one is changing the x. Okay, the way we speak about it is different, but the basic idea is we are widening it. When we multiply it times the y, it's called a vertical stretch or widening. We multiply the x, it's called a horizontal compression or stretching also. But it's kind of like the opposite, just like x is always the opposite thing. So when we have an n inside the x, so if you multiply this by 3, it's going to widen it by a factor of 1 over 3. We'll go through it. It's whatever. It's not that bad. All right. So using it here, we have I've just a random function. Now it is a parabola, mind you, but it is just a random function. This works with anything at all. So what we always want to do is we kind of want to follow PEMDAS. So we want to do what's inside parentheses first, do multiplication and division first, and then adding and subtraction. Okay, so when we look here, we want to do what's inside parentheses first. So we want to do the negative x thing. So when we do negative x, that's reflecting it through the y-axis, right? So we change x's sign, reflecting it through the y-axis. Through the y. I'm not going to write this every time. That was a bad idea. Okay, so this point right here, if I reflect it through the y-axis, it's going to be right there. This point right here, reflected through the y-axis, be right here. And this other point would go right there. So this is after we have done this. Okay? We've moved it so that these 3 points are now these 3 points. So the figure looks the same, it's just been reflected. Then this minus 2 here, this minus 2 says we're moving the x, negative 2. Now the opposite, we do the opposite of that. So we don't move in the negative direction, we move in the positive direction. It's just the way the x's work. So we take each of these points and we move, I really should have zoomed in. We do each, here we go. We do each of these points and we simply move them to the right too. So when you subtract from the x, you're moving to the right too. So we take this point, move it to here, and this point and move it to here. So again, it's the same graph, but you know, so pencil's good too. And then the final thing that we want to do is our y. So we're subtracting 3 from y, so we're going to move it down. This one works the same. So we're going to take each one of these points and move them down 3. So the easiest route, that's 4. The easiest route to take is do these one at a time in order. And now these 3 points are our final, is this whole thing put together. So you do them one at a time. Okay. And then when you connect them, you reflected, or you did that transformation on them all. A little messy, but you get the idea. So same thing here. Okay, start with inside the parentheses. So the first thing I want to do is add 5 to x. So if I'm adding 5 to x, that adding 5 means I'm moving to the left 5. Remember, it's always opposite of what you're going to think when it's that. Okay, so I'm going to just pick 3 points. So I'm going to pick the 3 obvious points, the vertex and the 2 roots, and move it over 5. So that's the first one. Here's the second. And then the vertex should be there. So it should look almost, those 3 points should look proportionally the same. So this negative x here, this negative f of x means I'm changing the y value. So when I change the y value, I reflect it through the x-axis. So the x-axis, that is, I think I can pick a different color. Right here, that's your x-axis, so we're just going to flip through that. So if I'm 4 above, I'm going to be 4 below. And it changes, you know, from being a downward facing parabola to an upward facing in this case. Okay? Most of the time it will with parabolas. And then these 2 points are right on the line, so these, you know, they're right, stay on the line. And then this positive 6, this means I move up 6. Okay, so move up 6, 6. And then we draw, oh, I should have changed colors, but whatever. All right, do your best. Try to make it curvy at least. All right, so moving down. If we have a function, can we write a new equation? So 2 possibilities. We're going to actually transform them graphically, or we're going to transform them algebraically. So this is our parent function for each one of the following ones, and we just simply want to transform them. So if I'm moving up 3, okay, so these are the 3 things. I'm moving up 3, so I'm going to be adding 3 to y. So the whole function is going to be adding 3. To the right 5, when I'm moving to the right 5, remember I'm going to be subtracting that from x, and reflected to the x-axis means I'm going to change the y. Change the sign of the y, make it negative y. So just doing all those 3, I think I can, yeah, I can still erase that. Okay. We're going to inside first, subtracting, we're moving it to the right, up 3, and then change the y. So this is unacceptable. Okay, that's it. And so I should do f prime of x is equal to this. This is a new equation. So left 4, so that means I'm going to be adding 4 to x. Reflected through the y-axis, I'm going to change it to negative x. And then down to, I'm going to be subtracting 2 from our y. Y is just our f of x. It is our whole function, so we're going to be subtracting from it. So our image is x plus 4 squared. I want to change my x there. Probably should have done that first, order of operations, and then subtract our 2 on the outside. So you start on the inside, move your way out unless it states differently. So a vertical dilation, so vertical means y. So we're going to multiply the whole equation by 2. So multiply all of y by 2. And then down 3, I'm going to subtract 3 from y. So it's just simply the image is multiply the whole thing by 2. Okay, it's outside the parentheses, and then down 3. Horizontal compression of a half, that means I'm going to multiply x by 2. It's messed up, but that's just what it means. You just flip it, and you put it next to the x. Reflected through the x-axis means we're going to change the y. And up 3 means I'm going to add 3. So multiply x by 2, meaning it's going to be inside the parentheses. Reflected through the x-axis, so y gets changed, that's the whole function, and then move it up 3. So hopefully that you understand. We will practice more. Have a great day.